In this video, we're going to do an example of a word problem that has to do with predicting and maximizing the revenue from a business. So you can imagine if you're a business owner, you're currently selling your product at some price. And you might be wondering, is that really the most money I could make? Right? Maybe I should lower the price so that I could get more sales. But of course, by lowering the price, that might involve some kind of trade-off on your revenue. Or maybe you should increase the price. And maybe that will so if you increase the price, maybe the amount that people will buy will decrease, but maybe overall your revenue might go up. So that's the trade-off here: is where exactly do you get the most money? Now in this case, I should mention that revenue. We're going to remember. Revenue is equal to the price that you sell, the price you sell it at, times the quantity that you sell. Quantity. And in this question, we're not going to take into account the cost of each item, but you can imagine that real businesses would. Okay, so in this question, it says that Olivia runs a snowboard rental business that currently charges $16 per snowboard rental. And on average, she gets 32 rentals per day. Let's actually write that out. Okay, maybe in a table. So currently the, let's say the price, let's call that P, is 16. And the quantity Q is 32. Now, according to some market research, maybe she paid a firm to help her figure out how to optimize her business. They found that every time that she decreases the price by 50 cents, let's say, 15.50, she's going to rent out 2 additional snowboards per day, 34. Okay. Let's write down one more. Let's say she decreases the price by 50 cents again, so $15. She's going to have 2 more rentals, so 36. And where does she maximize her revenue? So again, this is kind of like a brute force approach. I wouldn't recommend it, but just to get an idea, we know that the revenue is the price times the quantity. So the original price and quantity is 16 and 32. So in that case, her revenue will be $512. If she went down by 50 cents, she would get 2 more sales. 15.50 times 34 is 527. One more time, 15 times 36 is 540. Okay, so maybe it is going up, but it can't go up forever. That would be ridiculous, right? So where exactly is maximum? Well, here's how we're going to mathematically model it. Let's call n the number of 50% price decreases. Okay, so the first row, she's decreased the price 0 times. The first row, she's decreased the price once. Second row, she's decreased the price twice, and so on. So if she decreases the price n times, well, the price is going to be 16 minus 50 cents times n. And the quantity is going to be 32 plus 2 times n, right? 2 extra sales per price decrease. So the revenue should be the price times the quantity, which is 16 minus 0.5 n times 32 plus 2n. So that means we actually have a model for revenue now. Okay, if you tell me the number of price decreases n, I can predict how much revenue you can get. So for example, let's actually call this R of n in function notation. If I decide to decrease the price by $5, that would be 10 50-cent price decreases. So that would be R of 10. So in that case, it would look something like this. And when you do that calculation, that would be 11 times 52. So it's 572, for example. So now what we want to know is, how do you maximize this? How do you optimize the amount of revenue? So again, when we're thinking about a maximum value, you want to think about the vertex. How do you get in vertex form? Again, I'm going to do two different methods. You choose the one that makes the most sense to you, but you should know both. Method number one, since this is already factored, we can find the zeros to find the axis symmetry. So the revenue is equal to 0 when either the number sold, no, when either the price is 0 or when the quantity sold is 0. That corresponds to these two factors. When you solve these, you're going to get, I think 32 for the first one, and negative 16 for the second one. So you can imagine we have our n-intercepts here. Revenue is on the vertical axis. It looks something like this. Where's the sweet spot? It's right here. Okay, so the vertex, the n coordinate is going to be the average of these two, which is going to be 8. Finally, the revenue when you have 8 price decreases is going to be 16 minus 50 cents times 8 times 32 plus 2 times 8. Onto your calculator, that you're going to get okay, so the first one, 16 minus 4, which is 12. And the second one is 32 plus 16, which is 48. So 12 times 48, which is 576. To finish up the question, we're going to say, okay, so the question is asking what's the optimum price and how many snowboards can she rent? The price is not 8. Okay, remember n is the number of price decreases. So we're going to say, okay, the optimum price is 16 minus 0.5 times n, which is 8. That's 12. $12 per snowboard rental. And then the quantity is going to be 32 plus 2n, or 2 times 8. So it's going to be 48 rentals at this price. Let's do that one more time with a different method. Let's say we complete the square instead. Now in this case, maybe it doesn't make so much sense to do that because it's already factored, so method 1 is easier, but I'll show it to you anyway. So first, let's expand this into standard form. 16 times 32 is 512. 16 times 2n is 32n. Negative a half n times 32 is minus 16n. And then plus negative a half n times 2n is negative n squared. And negative n squared plus 16n plus 512. This is in standard form. So to complete the square, we're going to factor out a. A is negative 1, so we're going to factor out a negative 1 from the first two terms. Then we're going to complete the square inside. You cut negative 16 in half, that's negative 8. And then you square it, that's 64. So 64 is your magic number that turns it into a perfect square. You can't just add without subtracting, so let's also subtract. And finally, you're going to get n minus 8 squared on the inside. Let's make a little more space here. So this is going to be negative n minus 8 squared. Remember to distribute the negative. So it's plus 64 plus 512. And you're going to get negative n minus 8 squared plus 64 plus 512, which is 576. So that tells us that our vertex, which is like n and r, is going to be 8 and 576. That tells us that our maximum revenue of $576 occurs when n, the number of price decreases, is 8. So the optimum price, again, is 16 minus 0.5n, which is 16 minus 0.5 times 8, which is $12, same as we said last time. And then the quantity at this optimum price is 32 plus 2n, which is 32 plus 2 times 8, which is 48. So ultimately we get the same answer. To summarize, when you're looking at one of these problems, you're going to first make some kind of mathematical model. Okay. And then you're going to optimize by finding the vertex. Then once you found the vertex, don't forget to actually answer the question. There you go.